All right, kids. We're going to have some questions about a parallel circuit. And then after this, I'm going to give you some questions about a combination circuit. This is not from the beginning. I'll solve it later, but I'm going to expect you to already have some knowledge of this. And here we go. All right, here is a parallel circuit. You can freeze this on your screen to do your math. You can copy it. We have a 12-volt source. We have a 9-ohm resistor here. It could be a light bulb. It could be anything. Then we have a 6-ohm resistor and a 9-ohm resistor. I want to know all of these questions. So the first one is I'll say, what is the voltage drop across this bulb? Okay, question number 2. What is the voltage drop across this bulb? Question number 3. What is the current right here? What is the current right here? And then what is the current right here? All right, now you've already answered those. You either did well or you didn't. Like I said, you're supposed to already knew this. This isn't the intro video, but let's solve it. First thing, we've got 12 volts, and this is parallel, so these two guys absolutely have access to 12 volts. So these two bulbs are in a series. So we have 6 plus 9, so we have 15 ohms of resistance right across here. The voltage available is 12 volts from here. So if we're looking at from here to here, the available voltage is 12 volts. So we first need to find the current in the wire right here. Now it'd also be the same as the current right here. All right? So the current in the wire, V equals IR. 12 divided by 15 is our answer. So we take our calculator. 12 divided by 15 equals 0.8 amps. So now we know we have 0.8 amps here, 0.8 amps here. Now, if we're going to find the voltage drop right here, we can do V equals IR. The catch is you have to know the current first. The current right here is 0.8 amps. So 0.8 amps across a 6-ohm resistor gives you 4.8 volts. Boom. 4.8 volts. All right, now we know the current here and here. Let's see if we can find the current here. From here to here, there's 12 volts available because we can touch each side of the battery. So 12 volts equals I times 9 ohms of resistance. Do it like this. 1.33 amps. So 1.33 amps are available to this bulb. So what is the voltage across this 9-ohm resistor? Okay. The voltage we don't know. The current across that bulb is 1.33 amps. And the resistance is 9 ohms. And yep, that works out perfectly. 12 volts. And you know, 12 volts. So the voltage drop across this bulb, it gets all 12 volts to itself. So that's 12 volts. Now I'm going to go back. I'm going to add one more question to end this ed puzzle on parallel circuits. What is the voltage drop across this bulb? Okay, and the simplest way to do that is you can see that this series circuit touches these two parts of the parallel circuit, so there's a total of 12 volts. 4.8 of those bulbs are here, so 7.2 volts would be available here. And if you did the math, 9 times 0.8 amps, you would get 7.2 volts. All right, that's the parallel circuit part of this. Now we're going to do a combination circuit. All right, here's our combination circuit, everybody. Here's our combination circuit, all right? We have a 10-volt potential difference here, and we're driving a current across a combination circuit. In this combination circuit, there's a parallel circuit here with 3 9-ohm resistors that are all 3 in parallel. When you get out of the parallel circuit, there is another 9-ohm resistor that's in series with the parallel circuit. And then we come back here, and that's a complete circuit. And of course, it doesn't matter which way you go, all right? So the questions, I'm going to try to ask them in order this time. You're going to need to do some math. And then when you're done, I will show you the answers, okay? Again, you're already supposed to be familiar with combination circuits, and you should already have tried this. But here we go. What is the total resistance of this parallel circuit right here? The next logical question would be, what is the total resistance of the entire circuit now? All right? Once you know that, then you can find the current in, what is the current in the entire circuit? What's the current right here? And then the last question I would ask you is, what is the current in just this little part of the parallel circuit? And then I would ask you, what is the voltage drop across this bulb? And what is the voltage drop across this bulb? All right, here we go. Let's solve it. The total resistance of this circuit is going to be this formula. In a parallel circuit, resistance is 1 over RT, it's 1 over R1, plus 1 over R2, plus 1 over R3, etc. So it's going to be 1 over RT is equal to 1/9 plus 1/9 plus 1/9. Boom, boom, boom. We add that up, we get 3/9 is equal to 1 over RT. Flip that over, 3 ohms. So the total resistance of this whole thing right here, this whole thing, acts like 1 3-ohm resistor. Okay? Now, if we go from here, what is the total resistance of the circuit? Now, these two are in a series. So we have this 3-ohm resistor. This whole thing is a 3-ohm resistor. So 3 plus 9 is the total resistance of the entire circuit is 12 ohms. You just add those up because the 3-ohm and the 9-ohm are in a series. Now that makes our life a little bit easier. Now we can calculate the current right here just by using V equals IR. 10 volts is equal to I times the total resistance of 12 ohms. So to solve for our I, 10 volts divided by 12 ohms. We'll do that on the calculator. 10 divided by 12 equals 0.83. So 0.83 amps. All right? Now the next logical thing is we could say, what is the voltage right here? The voltage right here is 0.83 amps are coming through a 9-ohm resistor. So what must the voltage be right here? V equals IR, 0.83 times 9 ohms. 0.83 amps times 9 ohms. 0.83 times 9, boom. 7.5 volts are available across this bulb. 7.5 volts. So guess what? 7.5 plus what equals 10? That's right, 2.5. So the voltage across this entire circuit right here is 2.5 volts. So that means 2.5 volts there are available, 2.5 volts are available here, 2.5 volts are available here. Remember, this is one thing. So 2.5 plus 7.5 equals 10 volts. The last thing I would say, hey, the voltage isn't split up here, but the current is. The current can go 1, 2, 3 ways equally. The total current is 0.83 amps. So each one of these bulbs are only getting a third of that. So you could say 0.833333333 divided by 3 equals, there's only 0.27 or 0.28 amps available to each one of these bulbs. And then if you recalculated and you said 0.28 times 9, guess what? You're going to get 2.5 volts. That is a combination circuit. Good luck.